Artemis seeks knowledge of the width of Orion's belt, which is a pattern of stars in the Orion constellation. She has previously discovered the distances from her house to Alnitak, 736 light-years, and to Mintaka, 915 light-years, which are the endpoints of Orion's belt. She knows the angle between these stars in the sky is 3 degrees. What is the width of Orion's belt? That is, what is the distance between Alnitak and Mintaka? And they want us the answer, give us an answer in light years. So let's draw a little diagram to make sure we understand what's going on. Actually, even before we do that, I encourage you to pause this and try this on your own. Now let's make a diagram. All right, so let's say that this is Artemis's house right over here. This is Artemis's house. I'll say that's A for Artemis's house. And then, all right, let me say H. Let me say this is home. This is home right over here. And we have these 2 stars. So she's looking out into the night sky, and she sees these stars, Alnitak, which is 736 light years away. And obviously, I'm not going to draw this to scale. So this is Alnitak, and Mintaka. So let's say this is Mintaka right over here. Mintaka. And we know a few things. We know that this distance between her home and Alnitak is 736 light years. So this distance right over here. So that right over there. Everything we'll do is in light years. That's 736. And the distance between her house and Mintaka is 915 light years. So it would take light 915 years to get from her house to Mintaka, or from her Mintaka to her house. So this is 915 light years. And what we want to do is figure out the width of Orion's belt, which is the distance between Alnitak and Mintaka. So we need to figure out this distance right over here. And the one thing that they did give us is this angle. They did give us that angle right over there. They said that the angle between these stars in the sky is 3 degrees. So this is 3 degrees right over there. So how can we figure out the distance between Alnitak and Mintaka? And let's just say that this is equal to x. This is equal to x. How do we do that? Well, if we have 2 sides and an angle between them, we could use the law of cosines to figure out the third side. So the law of cosines, so let's just apply it. So the law of cosines tells us that x squared is going to be equal to the sum of the squares of the other 2 sides. So it's going to be equal to 736 squared plus 915 squared plus 915 squared minus 2 times 736 times 915 times the cosine of this angle, times the cosine of 3 degrees. 3 degrees. So once again, we're trying to find the length of the side opposite the 3 degrees. We know the other 2 sides. So the law of cosines, it essentially... Sorry, I just had to cough off camera because I had some peanuts and my throat was dry. Where was I? Oh, I was saying, if we know the angle and we know the 2 sides on either side of the angle, we can figure out the length of side opposite by the law of cosines, where it essentially starts off not too different than the Pythagorean theorem, but then we give an adjustment because this is not an actual right triangle. And the adjustment, so we have the 736 squared plus 915 squared minus 2 times the product of these sides times the cosine of this angle. Or another way we could say, think about it, is x, let me write that, x is equal to the square root of all of this stuff. So I can just copy and paste that. So copy and paste. X is going to be equal to the square root of that. And so let's get our calculator to calculate it. And let me verify that I'm in degree mode. Yes, I am indeed in degree mode. And so let's exit that. And so I want to calculate the square root of 736 squared plus 915 squared minus 2 times 736 times 915 times cosine of 3 degrees. And we deserve a drum roll now. X is 100 if we round. Let's see, what do they want us to do? Round your answer to the nearest light year. So to the nearest light year is going to be 184 light years. So X is approximately equal to 184 light years. So it would take light 184 years to get from Mintaka to Alnitak. And so hopefully this actually shows you it's pretty, if you are going to do any astronomy, the law of cosines, law of sines, and in fact all of trigonometry becomes quite handy.